Welcome back to another video. Partial differential equations, new video for Lemon's Math. Let's go. In this video, we're going to do an example of solving a PDE, but emphasizing two things. One of them being using the method of characteristics. So the one that you learned previously was separation of variables. This one is a new one, which is the method of characteristics. And then the second thing is dealing with a PDE using this method with a Dirichlet boundary condition. Each condition, so Dirichlet, Neumann, and in some cases no boundary conditions, has, I want to say, a unique case or situation, but it's just a different way of like solving it, or like how would you go about solving this type of question with this particular boundary condition. So we're going to go ahead and get started. As I mentioned, we're going to solve a PDE, so we have to find the unique solution of the following PDE, which is the second partial derivative, well, 20 times the second partial derivative with respect to x minus the second partial derivative with respect to x and t minus the second partial derivative with respect to t. From x is greater than 0 and t greater than 0, given the initial conditions of u of x0 being e to the x, and the partial derivative with respect to t evaluated at t is equal to 0 being equal to e to the x as well. And then we're also given the boundary condition of u of 0t being equal to 0 for t greater than 0. So a nice little neat trick-ish when solving the method of characteristics, when solving a PDE using the method of characteristics, it is really simple to find the general solution. And so the way we'll do that is if we look at our table of special cases, where if we're given a PDE in this form specifically, then we can identify what A, B, and C is. So in this PDE, our A is equal to 20, our B is equal to -1, and our C is also equal to -1. And so now what we have to do is, there are 5 cases in which we can jump to when solving the general solution. The first, and it has to like satisfy 2 conditions. The first condition is checking if A and C are equal to 0. As you can see, both C and A are not 0, so that eliminates one of the cases. And then the next condition is checking if discriminant, I think that's what it's called, is equal to 0. And for the discriminant in terms of a quadratic, it will be b squared minus 4ac, which is equal to 1 minus 4 times 20 times -1, which is 8 plus 80, which is 81, which is not equal to 0. So that means we're down to one of 2 cases. Either case can work. The only thing that you're changing is where are you adding your roots. So in one case, you'll have f of x plus rt plus g of x minus rt, and then there's another case where you have x plus, or f of x plus f of x r, or rx, plus t plus g of rx, or I guess, well, this is supposed to be plus r1, r2, r2, r1, x plus t. There you go. Okay, I was confusing myself. So either of these cases work. I'm more favorable in using the one where t gets multiplied. So to find what our roots are is we just solve the quadratic equation, in which it is now in the form of a plus br plus cr squared, which will be 20 minus r squared, and that can be factored to 4 minus r times 5 plus r equal to 0. So our roots become 4 and negative 5. And so our R1 is going to be 4 and our R2 is going to be negative 5. So our actual general solution, u of xt, is going to be f of x plus 4t plus g x minus 5t. But we're not done here. We need to find a unique solution that satisfies these two initial conditions. So we're going to go ahead and do the initial conditions. And so we're going to do the most simplest one, which is the initial condition where we just get u of x0 equaling e to the x. So this one is just a simple plug. Plug it into the solution. And so this will be f of x plus 4 times 0, which would be 0. So we get f of x, and then same thing here. It's equal to g of x. And then we know from the initial condition this is equal to e to the x. So now we're going to plug in our second initial condition, which is, well, before we do that, it tells us to take the second part, or not the second, the partial derivative with respect to t. So u of t of xt is going to be equal to the partial derivative of f of x plus 4t over dt times the partial derivative of g of x minus 5t over, or with respect to t. And this can be rewritten and simplified down to 4 times f of x plus 4t minus 5 times, or f prime, times g prime x minus 5t. And then, so now when we evaluate this to 0, we will get 4f prime of x minus 5g prime of x is equal to e to the x. So what do we do now? We have two equations, 4 unknowns technically, because we don't know f of x nor g of x, and we don't know its derivatives. But we can manipulate the second equation as you can do with like anything in algebra. Whatever you do on one side, you do with the other. But we're going to take it to the extreme, and instead of adding or subtracting, we are going to integrate both sides. And what ends up happening with respect to dx, what ends up happening is that you'll get 4f of x minus 5g of x is equal to e to the x. So now we have two equations with two unknowns, and we can just use any form of method to solving a systems of equations. It could either be a matrices or substitution. I'm going to do substitution, and I'm going to be substituting f of x. So we're going to rewrite equation 1 as f of x is equal to e to the x minus g of x. And then we're just going to plug it in to the second equation. So now we get 4 times, or 4e to the x minus 4g of x minus 5 of g of x is equal to e to the x. Oh, and I forgot. This is supposed to be a plus c. And so now we're going to combine like terms, and we end up getting negative 9g of x is equal to, if we subtract both sides by 4e to the x, we'll get negative 3e to the x plus c. And so this ends up being, if we divide both sides by negative 9, we get that g of x is going to be equal to 1/3 times e to the x plus c. And so now we know what g of x is. We can use it to substitute back into the first equation, and so we end up getting that f of x is going to be equal to e to the x minus 1/3 of e to the x plus c will actually give us 2/3, 1/3 multiplied by 2 e to the x plus c. C? Yes. Yeah, and so this will be our solution, or our unique solution to this ODE, PDE. So our actual final answer, kind of, is instead of e to the x, we're going to substitute e to the x would be x plus 4t and x minus 5t, depending on which one it is, of f or g. So for f of x, it will be 1/3 multiplied by 2e to the x plus 4t plus c. Oh wait, actually this won't be plus c, this will be, no, yeah, this will be plus c. This will be minus c because we divide both sides by -9, and so technically c over 3, and this would be c over 3. So yeah, this would be minus, factor out the 1/3 for both f and g, so we 1/3 2e to the x plus 4t plus e to the x minus 5t, and then the plus c over 3 gets canceled out with the negative c over 3, and so this will be our final answer. But there is a little catch because this is not our complete answer. This will only be valid for x being greater than 0, t being greater than 0, and x minus 5t being greater than 0. So what that essentially means is if we have x minus 5t being less than 0, then this solution just becomes invalid. So what we have to do is now we have to find another-ish, well, yeah, we have to find the second part of this solution that will satisfy the x minus 5t being negative. And the reason why we only care about the x minus 5t being negative instead of x plus 4t being negative is because since x and t will always be positive, then x plus 4t will always be positive. And for the x minus 5t, there will be some cases where it will be positive, but there will also be other cases where it will be negative. So we will want to deal with the cases where it will be negative and see what we get. And so to do that this is where our boundary condition comes into play. So if we use the boundary condition of u of 0t, I believe, is equal to 0, we get that u of 0t will give us f of 4t plus g of negative 5t, and that is going to be equal to 0. So what do we do now? Well, since we're looking for the x minus 5t being negative, we'll want to start playing around with the function of g of negative 5t. So what we're going to do is we're going to rewrite what g of negative 5t is equal to, and it's just literally subtracting both sides by f of 4t. So we end up getting that g of negative 5t is equal to negative f of 4t. And the nice thing about this is that we already know what f of 4t is. This is equal to 1/9 multiplied by, well, yeah, that's actually, yeah, I already technically wrote it. 1/9 multiplied by 6e to the x minus 4t, but since x is 0, it's just, well, not x minus 4t, x plus 4t, but since x is 0, it would just be 4t. And it will be plus plus, yeah, plus c over 3. That's cool. And then we just bring down the negative. So this would be negative 1/9. So cool. So technically we already found what g of negative 5t is. So now what we're going to do is we're going to do a little bit more manipulation. And what I mean by that, we're just going to transform negative 5t to just being a single variable. And so what we're going to do is we're just going to let some variable z be equal to negative 5t. So what that means is that t is equal to negative z over 5. And so what we end up getting is we get g of z is going to be equal to negative 1/9 times 6 e raised to the negative 4z over 5 because we're substituting t plus c over 3. And this will be true when z is negative. Yeah, when z is negative. I'm gonna say negative 0. When c is less than 0, and now if z is greater than 0, then that means we have g of z is going to be equal to the same thing that we found in the first solution of like what g of x is, which would be this portion right here. So it would just be 1/9 multiplied by 3e to the, well, it's just minus 5t, which is z. So 3e to the z plus minus c3. So now we notice that g of z actually has, or is a piecewise function with two different solutions, where one is satisfied the case where z is negative and the other one's positive. And so the z is negative part actually encapsulates the portion of the x minus 5t being negative. So what that essentially means is that our true solution is actually a piecewise function. So it is actually equal to the original one that we found, which will be the 1/3, yeah, 1/3 2e to the x plus 4t plus e to the x minus 5t when x minus 5t is greater than 0. And then the other case will be this portion right here. So it will still be, factor out the 1/3, and then it will be f. Where's f? F will stay the same. So it'll be 2e to the x plus 4t. And then it will be minus, because of the negative right here, minus 1/3 2e to the, this will be the negative 4z over 5, but we already know what z is, so it'll be negative 4 times x minus 5t over 5 plus c over 3, and then this is when x minus 5t is less than 0. So we have two solutions, or not two solutions, we have one solution, but the solution isn't a piecewise function, and this is the complete solution as it will satisfy the positive case for x minus 5t and the negative case for the x minus 5t. So that'll be it for this video, and I'll see you in the next one. I think we might do another one of these.